I am Barry O'Donovan from INEX. INEX is the Internet exchange point for the island of Ireland. We have two LANs in Dublin, which are sort of national LANs, about 100 members, and we have a smaller sort of startup exchange down in Cork called INEX Cork. This presentation today is about IXP root servers and how we are starting to filter those now with RPKI. This presentation is sort of split into three sections. We're going to have a little bit of introduction to a couple of concepts. Then we're going to talk about the main meat, which is root servers and RPKI and filtering. And then we're going to have a look at implementation notes. Let me start with... I can keep going, but... I'll tell you what, we'll talk about Internet Routing Registry databases. So, in Internet Exchange Point, I think the easiest way to think of an Internet Exchange Point is think of it as a big switch. It is a little bit more complicated nowadays. Most of our switches are in fact routers. We run eBGP as an underlayer network, and the peering fabric itself is VXLAN. But again, think of it as a big switch where our members come, they connect to the switch, and they can start to exchange traffic with each other by peering with each other with BGP. So you do a BGP peering session with another member of the exchange, you exchange routes, and you start exchanging traffic. The problem with this is that it doesn't scale very well. So if you have an exchange with 10 members, that's about 50 sessions if everybody was peering with everybody. But if you have an exchange with 100 members, that's 5,000 sessions for everyone to peer with everybody. So this is where I am. Okay, great. So this is why we need root servers. So a internet exchange without root servers looks like the top image there, where everybody is peering at everybody. If you were the 101st member to join the exchange, you have to go and talk to 100 other people to start exchanging traffic with them. Whereas if we use root servers, you just peer with the root servers, you advertise your routes to the root servers, and the root server's job is to share that with all of the other participants, and vice versa. You can see from this that we obviously have two root servers for resiliency, but you can see the root servers have become a very essential part of the exchange. If the root servers fail, you effectively lose an awful lot of traffic very quickly. You also need to be sure that that the routes you're getting from the root servers are trustworthy. So that's mostly what this talk is about, is demonstrating that if you use the root servers at INEX or any other exchange that uses IXP Manager, that you can trust the routes you're receiving. So how we normally filter routes is we use Internet Routing Registries. These are databases, and a number of them exist, but they're of varying quality. Typically what we look, when a member joins, if he's from the RIPE region, we are going to use the RIPE Internet Routing Registry database, and with their ASN or their AS set, we're going to pull all of the prefixes that they have registered root objects for, and we build a filter for our root server so that they can only advertise those routes. If they haven't created a root object for a particular prefix that they have, we're not going to accept it. The problem with Internet Routing Registry databases is that there's a few of them of different quality, as I said. Information gets stale, it's inaccurate, and also it's quite difficult to, if you're a larger network, to figure out exactly where you should be registering all of these routes. So the internet community have created this thing called RPKI, and the essential element of RPKI is a ROA, a root origin authorization. And a ROA is a cryptographically secure replacement for those root objects in routing registries. In the RIPE region, you can only register a ROA through RIPE for IP space that RIPE have allocated to you. So you go into the Lear portal, you click a few different links, and RIPE will create and sign the ROA for you. It will maintain that ROA for you, but it will only do that for resources that RIPE has allocated to you. The ROA contains the same information as a root object that we're interested in, which is the prefix, the AS number, and then it adds one more piece, which is the maximum path length. And that is to say, if you had a /16, for example, that you were advertising as 2/17s, you'd put the max length in there as /17, which means that that would be your /17 advertisements would be valid. To try and give an example of how popular or not ROAs are and how much networks are using them, Last week I did a quick check on on our root collector on INEX LAN 2. And LAN 2 is a little bit more interesting than LAN 1 because LAN 2 has about 80–90% of the members, but it particularly doesn't have members like Hurricane Electric who inject about 70,000 prefixes, which kind of makes the information a bit harder to see. So on INEX LAN 2, what we find, which was surprising to me, is there's 35% of the prefixes that we learn there are RPKI valid. So they have ROAs created and they're validating as correct. It's even more interesting for V6. Nearly 50% of all the IPv6 routes in INEX are RPKI valid. So I was expecting maybe 20% on V4, but it's quite a lot of routes. On the reverse, how many of them are invalid? Well, it's 0.6%. So it's only 100 routes of about 17,000. But when you dig into that data, what you find is that about 100 of those 106 routes are actually from a single member who transit a lot of routes for a lot of different networks. So for most of the INEX members who have ROAs for their prefixes, they all are RPKI valid. There's very few INEX members who actually have issues with RPKI invalid routes. The other thing to mention here, for those of you who aren't aware of IXP Manager, IXP Manager is a project that we started in INEX and open sourced about 8 years ago. It's a full stack management system for IXs, but I think the key thing here is for what I'm about to show you in the work that we've done on root servers is that we don't just do it internally at INEX, we do it by developing it on IXP Manager and then we start using it ourselves. And it means that the other 70 or 80 IXs around the world that are using IXP Manager get to roll out this stuff themselves as well. In particular, we've always worked extremely closely with LUNAP, and I understand LUNAP are about to roll this stuff out over the next couple of weeks as well. So what you see here that's live at INEX is coming to LUNAP very soon as well. So as part of the work we've done on RPKI, we didn't just limit it to RPKI. What we did was we looked at our overall root server ecosystem, and we did a complete refresh. So RPKI was just one element. We also switched from Bird version 1.6 to Bird version 2. We did a complete rewrite of how we filter routes, and particularly we started using internally within the root server an awful lot of large community tagging, and that's so that we can show our members what routes we're filtering and why, and you know, create some tooling in the UI to help our members better see what's actually happening to their routes in the root server. We also wrote a sort of microservice for Bird called Birdseye. And we wrote that because Bird doesn't have its own API. So in order for us to have a looking glass and to build that kind of tooling, we built a tool called Birdseye, and we upgraded that as well to work with Bird version 2. It's another open source package. It's particularly used for IXP Manager and the looking glass functionality. So like it doesn't support OSPF and things like that, but it certainly is extensible if anybody wanted to do it. The good thing, we've spoken to the Bird developers a few times, and it sounds like they're going to start moving towards creating their own API as well. So the medium-term goal for Birdseye is that we can remove it entirely. So in terms of Bird 1 to Bird 2, I imagine a lot of people in this room use Bird within their own networks. The main reason that we wanted to move to Bird 2, besides staying current, is it has this thing called RPKI to router support. And RPKI to router is a protocol that gets all of those ROAs that exist in RIPE and ARIN and the rest of the rears, and it feeds that to Bird through a TCP socket. And we'll see a little bit more about that later. But it means that with that protocol, we don't have to get all these ROAs, stick them into a config file, reload Bird, as we do with the IORDB stuff. We can just use a protocol that feeds and keeps those ROAs updated in real time. The other big change in Bird 2 is Bird version 1 used to have a different daemon for V4 and V6. Bird 2 has collapsed that into one daemon, as well as adding support for other things. For us, we've kept V4 and V6 in separate daemons. It's just the way our provisioning system works. We also think it will scale better, and we also think it'll be a little bit more robust. And then in the main, in terms of any of you are running Bird 1 and are thinking about Bird 2, the config changes are actually really, really small. It's mostly around putting protocol-specific stuff into IPv4 and IPv6 stanzas. And there's a little few other changes, like the master table is now master 4 for V4 and master 6 for V6. So this is how we now filter routes that our root server learns from our members. The first few steps are very basic sanity checking steps. So if someone's trying to advertise something smaller than the /24, we're going to filter that out. /24 for V4 and /48 for V6 is kind of where the industry has settled in terms of how the smallest prefix you can advertise into the default free zone. That is configurable, but they are the sensible default values. We also filter Martians, private IP addresses, 192.168, etc. In whatever prefix you're advertising to the root server, we're going to make sure there's at least one AS in the path. In testing this, we could find that you could actually advertise a root without any AS path in it. And we're going to make sure there's no more than 64, because if you're going that high, something's pretty wrong with your network, I think. We're going to ensure that the peer AS is the member AS, so that kind of will just prevent some misconfigurations. We're going to prevent next hop hijacking, and that's where a member may come along and say, here's the prefix I want to advertise, but instead of routing that to me, route it to somebody else. So there's a very interesting case in Brazil where a smaller network effectively did next hop hijacking to get free backhaul from the incumbent network. We're going to filter known transit networks, and that's a new thing that we've done here. There are a number of networks, typically the types of tier 1 ISPs, that have said that they do not peer at IXs, nor would they take transit from anyone who peers at an IX. So, which is to say that if any of these ASs appear in an AS path, it's going to be a root leak, it's going to be misconfiguration, or it's going to be something nefarious. So we filter those out as well. So anytime we see those ASs in an AS path, those prefixes will get filtered. And then we're down to the business end. It's fair to say that anything covered by 1 to 6 would be covered by 8 and 9 anyway. But if we did that, we wouldn't be able to give the members specific information as to why a prefix is being filtered. So when we get to 8 and we do an RPKI check, when we look at a prefix that's advertised from an origin AS and we do an RPKI check on that, there's one of 3 different results. It's either unknown, in which case there's no ROA, or it's going to be valid, in which case we accept it and we're done, or it's invalid, in which case we drop it and we do not pass that on. If it's unknown, we're going to continue on to the standard IORDB filtering. So RPKI and IORDB will coexist for quite some time until the saturation of ROAs is well over 95%, I imagine. How this looks in Bird, the sort of bounded green box here is Bird's inner workings for our configuration. AS112 is an example member. So AS112 is going to come along and it's going to advertise its prefixes to Bird. What we've done in Bird is we create a per AS routing table. So it's a private routing table for each network. And as we import those prefixes, we run them through those 9 filtering steps that we looked at. We don't reject them at the edge here. We bring them into the routing table, but we tag them. We tag them with, if we're going to filter them, we're going to tag them with the reason we're going to filter them. If they pass validation, we're going to say an informational tag, this is RPKI valid, or it's RPKI unknown but IORDB valid. So we bring that information into the root server so that we can give that UI tooling that you'll see in a little bit. Once it's in the routing table, we want to get into the master routing table so that it can be propagated to the other members, and that's where we filter out the bad prefixes that we don't want to pass on. Once it's in the master routing table, it gets sent on to all of the other networks. This is an example of the kind of large communities that we're using within IXP Manager. 43760 is INEX's root server AS number. So, for example, large community tag 43760-1001 is an informational tag within the root server to say that that prefix is RPKI valid. On the other side of the page, you can see all the 1101s means filter this prefix. Do not propagate it, do not pass it on. But we have a tag here that will tell us why we're filtering it, for example, IORDB invalid. On the reverse, all of the other members have advertised prefixes into the master routing table, clean prefixes. We've already filtered out the bad stuff. We want to pass these on to AS112. So AS112, as well as advertising routes to the root server, is going to want to learn routes from it, from all of the other members. In the reverse pipe, there is standard IX root server communities that most root servers support. And that is where you might come along and say, right, I want to advertise my prefixes to all of the participants of the root server, except maybe one, say AS112. In that case, I would tag my routes 0:112. And at the AS112 pipe, that's where we'd say, whoever sent this in didn't want it to get to AS112, so we're going to filter it here. Otherwise, everything else gets through and gets sent on to AS112. The last thing we do before we send them off is all of those tags that we added, those informational tags, we strip those out. They should only exist in the root server. Their only purpose is to provide that tooling and the looking glass and stuff like that. What we want our members to get out of the root server is exactly what another member had sent in. So full transparency. So just some implementation notes then. One thing I kind of glossed over was this RPKI to router protocol. And there's 3 software daemons that support this. We'll see them in a second. They're called cache servers or validators. And what they do is they go off to the trust anchors, which is essentially the 5 rears, so RIPE and APNIC and stuff. They pull down all of the ROAs that have been registered with those rears, those trust anchors. And then locally, it does all of the cryptographic validation. And then for all of the ROAs that are cryptographically sound, it stores them in local memory. And when a router comes along with the RPKI to router protocol, it will send all of those ROAs onto the router. If later any of those ROAs become invalidated, it'll do an update over RPKI router to take that out of the router's ROA table as well. So the 3 pieces of software that do this at the moment is, the first one is RIPE NCC's RPKI Validator 3. This is written in Java. The 4 commands there will get that running on your Mac, for example, where you can open up a web UI and you can see RIPE's validator go off and download the ROAs from the trust anchors, validate them, and then there's a nice UI where you can look up a prefix and see what ROAs might exist for it. The second set of commands, the RPKI to router daemon, is a separate piece of software that interacts between routers and the local cache. The second one is called Rootinator 3000. This is from NL Labs. It's written in Rust. It's very nice. It's very low overhead. It's really easy to install, and it's quite stable. And the third one is Cloudflare's RPKI toolkit. So all those commands are in the slides. You can have a look at that yourselves if you like. Again, this is very much low overhead, and it's very easy to install as well. What we have on docs.ixpmanager.org, which is a link on my last slide, for each of these we've given, these are just instructions if you want to play with them. If you want to install them in a production-ready environment, we've given full documentation on how to do that for each of the 3 of them on our documentation website for IXP Manager. This is how you would use a RPKI to router service in Bird. It's quite easy. The first thing you do is you define a routing table that's going to hold IPv4 ROAs, in this case a ROA 4. A table is called T_ROA, and then you just define a protocol. And the protocol just needs to know what table to store the ROAs in and what their mode IP address and port of the validator is. The other timers are just, for example, expire keep. That's 2 days and seconds. That means if the validator disappears, don't just get rid of the ROAs. Keep them in memory for 2 days. Gives network engineers a chance to go and fix whatever the problem is. We would obviously configure 2 of these. So we'd run 2 validators, and we'd take the ROAs from 2 different sources into the table. Once you have this table of ROAs in Bird, you want to use that information to make routing decisions. So if you're learning prefixes from a BGP peer, the way you would check those prefixes in Bird is use this ROA check command. And the ROA check command just requires the table where you've stored your ROAs, the prefix, which is net, the prefix that you want to check, and the origin ASN, which in Bird is bgp_path.last. And that ROA check will give you 1 of 3 results, the ones we've already talked about. It's ROA invalid, in which case you're probably going to want to reject it, ROA valid, or ROA unknown. In terms of implementing this at INEX, we put all this together and put it live last February. INEX has 2 root servers and a root collector per LAN. The root collector is a management and administrative tool that we use for diagnostics and for monitoring and things like that. All members have to peer with the root collector, but it is not a production machine. It's just, as I say, for monitoring and admin tasks. So the first step we did was we rolled this out on the root collector, which is the easiest thing to do because it's not going to affect anything. And when we did, we found that of the members that we were interested in, which is to say the ones that also peer at the root servers, we found only 4 issues, and they were fairly small issues. One had a more specific advertise than the ROA allowed for, which is to say they were advertising as 2/17s when their ROA said a /16. It's very easy for them to fix. One member was still advertising space that they transferred to a different network, and that other network had created ROAs for their new space. This wasn't malicious or lazy. I suspect there was just a backdoor in place because it was heavily prepended. And for example, one member didn't really understand the full concept of ROAs and created a ROA for their upstreams AS rather than their own AS as the origin AS. So these are all easy to fix. We told our members on an FYI basis. We gave them about 2 weeks grace before we started the rollout on the root servers, which we did a week apart. And I'm glad to say that we had no issues, certainly no issues that related to RPKI or any of the filtering stuff that we've went through. One main issue we had is RIPE's validator kept crashing. Its disk and memory utilization is kind of like this. So it's not really production ready. As I say, it's a great tool to spin up and use the UI to interrogate ROAs, but for production, we use Rootinator 3000 and Cloudflare's RPKI toolkit now. And since we put those in place in February, we've had no issue with either of those. There is an awful lot in this talk, I'm aware of that. You know, it's about BERT2, it's about root collectors and root servers, a huge amount of filtering, community tagging, large communities, RPKI, and we haven't even discussed any elements of the cryptography of RPKI. For most of us, we don't really need to understand it. You log into the Air portal, you click about 5 times and your ROAs are created, RIPE will just look after it for you. But there is a lot in it, so I hope I haven't gone through it too fast. If anyone wants to see some of this in action, www.inex.ie/IXP/LG will get you to our looking glass. So this is an example of our root collector in Cork. And if we take a look at this, we can see that Aircom, for example, are advertising 77 prefixes to that root collector. If we click on this, what you'll see is, with their list of roots through the looking glass, and this is all bird's eye on the back end, is you'll see these little warning symbols. And those warning symbols mean that these prefixes are being filtered. And we can click on the details across from that root. And down the bottom here, if you can make it out, there's 2 blue labels. And they're the informational communities. So what we can see here is this is saying RPKI unknown, but the red means is saying that it's IORDB filtered. So there's no RPKI. There's no RPKI ROA for this root, but there's also no root object. So we're filtering this at step 9 in that chain of filtering steps we went through. We've also made it very easy for members. If you log into XP Manager, you'll see this filtered prefixes tab on your home screen. And when you click on that, what it will do is it will run around to all of the root servers and root collectors in real time and give you a list of what prefixes we're filtering and why we're filtering them. And that is it for me. If anyone has any questions. In the meantime, our INEX's Twitter handle, my own email and all that is there, and there's a few links as well.
Do we have any questions? Do we have any questions for Barry?
It's no problem, I'm around all evening anyway, if anyone else wants to come and talk to me about this stuff.
No questions? Oh.
Hi, Will from LONAP. Your list of ASNs that should never be seen on root servers, where did that actually come from?
That came from Job.
Okay.
Job Schneiders.
The reason is at least one of those ASNs is connected to our root servers. So
we'll have to have a word with Job. The one thing on that list is it's a skinnable template, so you don't need to wait for XP Manager updates to affect that list. They can be edited in real time, so there's no issue with that.
Oh, great, thanks.
Okay, thanks very much, folks.
Thank you, Barry.